Hello guys, this is Danny from Moralis. A couple of days ago I had a discussion with one friend of mine which is very well versed in real estate about land in the metaverse. We have very good discussions about what opportunities are there and what is hype. But that brought to my mind the idea of building technically a project that is similar to those famous projects such as Decentraland or Sandbox, where you can buy your own land in the metaverse and you can build actually your own metaverse. And since I am kind of a big Pokemon nerd, I wanted to do that in land that looked similar to Pokemon. So let's check it out. I have this project that is called Moraland because it's Moralis land. And we're going to move about this map that we have here where we have different plots of land. As you can see, as we move, we have a plot ID that is different for each of these plots. And we have the coordinates of the plot, which is kind of like the physical identifier of the plot in our metaverse, and the location coordinates, which are kind of like physical coordinates in this digital world. Also, as you can see here, some of the plots can be claimed, but some of them cannot because they are what we would call commons. So let's say that I want to claim this nice coastal plot here. I could click the bottom claim, and this is going to trigger my MetaMask. And here I will be able to claim this one. Of course, I am not assigning any price here. This is going to be something just to claim the land, but not actually buy it. You could have some mechanisms to allow people to actually enter this claiming stage in your own project. That will be out of the scope of what we're building. But as you can see here, I claimed the land and I got my transaction confirmed. And if I go to the Polygon Explorer here in Moraland and I try to look for this transaction, I can see it here and I see that this token ID was assigned to my address here in the Polygon Mumbai testnet. So this is what we're going to do today. We're going to learn how to build our own metaverse and be able to allow people to claim land in that metaverse. How you are going to decide who has access to claim land, well, that will be on you, but only with this content. This is going to be quite a lot to cover, so I hope you enjoy. Let's get to it. We are going to start by reviewing the folder structure of our project. First, we're going to have contract, which is the contract that we are going to use, which is nothing more than a very simple ERC 721 contract based in the Open Zeppelin library for NFTs, because at the end, this land that we are going to be working with is a deed of property, which is an NFT. Then we're going to have the maps, which is the graphics of our land, and then we're going to be working in the front end. Actually, what we are going to do first is review the maps a little bit. Then we're going to enter to the front end, and then we're going to integrate that front end with our contract. Let's continue with the maps. For the maps, we have the following here. We have this metaverse land, which is actually our map. And as you can see here, is sort of an island. And the reason is this layout. What I have chosen is because it's very easy to work with anything that is an island, because we have water all over us. That will help us a lot later on in the logic. And also we have a square. So this is a very basic layout that we are going to be using. I want you to notice as well that we have each plot here is very regular, and also even the parts where we don't have plots that are covered in water most of the time, they actually have the same dimensions that our plots of land have. So to be more specific, each of our plots of land is made of 9 tiles of height by 9 tiles of width. And each of these tiles is made of 12 pixels. You could work with any map you want, and you could make that map as big and as elaborated as you like. But actually, for doing that, you will have to go to a tool and actually redesign everything, which I will not be going into a lot of detail for this tutorial. I will just give you some tips. So for example, what we have here, which is our Metaverse land or the Moralis map, is actually made with this asset pack that I downloaded from a website, and I will put those links in the README for this project if you want to go there and find some assets. So these assets are here, and this is what is defining the dimensions of our tiles. In this case, in the case of this asset, each tile has 12 pixels. Then what we are doing is creating a map that has that kind of matrix of tiles in a tool that is called Tiled, that I will also include a link to in the README of the repository of this video. And we basically design our Metaverse land in that tool. The tool is called Tiled, and you can look in YouTube other tutorials on just how to use it, because that's a subject on its own. And basically what you will get as output, and don't get scared about this, is just a bunch of matrices that will have certain encoding. But this is very similar to a CSV file, and as you can see here, we have different layers of a map, and then basically you export that to a graphic. As I was explaining, there are tutorials how to work with the tiled software, which is free to use, but they accept donations, which I encourage you to give. And basically they offer you the tools to generate these kind of maps based on gaming assets. And that's the way that I produce this one. In our tutorial, we're going to be working directly with this one according to the characteristics that I told you before. We are going to get to animate that map right now. Follow me to it. So here we are going to start working in our project. For this, the first thing that I want you to do is switch to the Moralis front end directory of our project here in your terminal, and also start to take a look to index.html, which is going to be our starting point. This is going to be super easy. It's just a template that you just can copy and paste. We just have a title here. We have our standard HTML document tags. And then we are importing the Bootstrap library to make things look cuter. Then we divide our screen in 3 sections. In one, we're going to show the map. In the other one, we're going to show the current plot. And in the lower section, we are going to display any notifications. And that's it. And to close, we just import the JavaScript needed to run the Bootstrap library. We import Moralis, and also we import our logic file, which is here is called a logic.js. To begin with, what we're going to try to do is to check what is showing right now in our screen, and also to make our maps appear in the screen. So for this, we're going to first run a little Python server here to have some way to enter into the website. And we're going to go to the web to check what is going on here, and we'll refresh. And here we have our HTML. It's everything that we have in the document right now, but we cannot see our map, we cannot see the current plot, and of course we don't have any of the coordinates, and the button doesn't do anything. But this is our template. So right now we want our map to be drawn, right? So let's go back to our Visual Studio Code. And let's try to make that happen. To begin doing that, we need to start working in our JavaScript file, and we are going to do the following. We are going to define certain constants that, as I mentioned, are very important to be able to work with our map. So for this, we are going to first define everything that is related to the dimensions of our map. And since it's not going to be fun semi-typing a lot, let's start just by copying the code little by little. So we have our graphic constants here, and we have the map management constants. We have the constant tiles, which has a value of 12, and that's in pixels. So we're going to write here in pixels because this is the size of a tile in pixels, either for height and width is the same, so we just keep it as one constant. Then we have the plots, which are made of 9 tiles, and that will give us the measure in pixels as well. So we're going to comment this, that is in pixels. And then we have the roads, which will have always a dimension of 2 tiles, also in pixels. Now we want to figure out some initial offsets, but we are going to comment these ones for now because I want you to check the base scenario first. So we have that. We have defined some basic logic regarding our actual map. Now, when you make a drawing in the HTML document or a graph or an image, you need a canvas to be able to paint it, and we have it here, the canvas of our map, which is called main canvas. So we need to get that element to be able to work with it, and that's the second thing that we're going to do, and we are going to get it right now. So let's get it. We have canvas and context. So first we're loading this main canvas from our HTML document, and we're getting its context, which is what we will need to work with it. And since we are working in 3D, we just need XY coordinates, so we're getting the context in 2D. That's it. Now we need to define a thing to be drawn in that canvas, right? And what we are going to draw is only the following: an image. So we have the constant word image, which at this moment is just going to be an image. So that's it for now. Now we are going to set the function that is going to get us the first view of our map. So we're going to start with that. And for that, we are going to do the following. We are going to draw a canvas there with our picture that we're loading. So we're going to have that with a function here, and we're going to start commenting that as canvas for drawing functions. So we are going to have this function over here, and we are going to have that canvas defined. So we're going to define that our main canvas is going to have a dimension of 3 plots plus 4 rows of width, and is going to have the same dimensions for its height. And this one we're going to leave for later on. And then in that canvas, we are going to draw this image, which is our Metaverse land, which we should have here, but I think that's not its name. So we have image Metaverse land. No, it's not called that way. It's called Moraland, right? So we're going to change that name of that image yet. Now, when this image is on load in memory, we are going to do the following. We're going to comment this part right now because we're not going to be using that just yet, but we are going to draw our image. We're going to draw an image with our word image here and in the context. So we're going to get our context, which we have here, which is main context. And we're going to draw image. And what we're going to draw is the word image. And we're going to draw it in the 0, 0 axis. And after we do this, let's see what happens. The only action that we're going to have in our website right now is try to run this draw canvas. And we load. And here we have it. Our image or our map is being drawn, but it looks a little bit weird, right? We have all the water in the center and our plot starts to show around here. And actually what we want to have is that we want to have the plot that is in focus to be in the center of this canvas. And we're going to have another canvas here to show it. And then that will allow us to animate it very easily later on. You might be wondering why we are calling this draw image method here inside this onload event. And the reason is that we want to draw the image only after the actual image source is already loaded in memory. If this one triggers first, then it's very likely that it will try to draw it before it's present in memory, and that will cause the image to not appear at all in the browser. So right now it might work because actually my image might be cached in the browser, so it might work. And I can just comment this part over here and just trigger it this way. But we are going to have to fix this one later on. So we have seen that our map is drawn, but is not actually that nice because it's a little bit out of focus. We want our initial plot to be in the center because that will help our animation later on. So we need to have some way to move the map up, right? And the way that we do that is modifying these values over here. Instead of starting our map being drawn with these 0, 0 coordinates, we are going to do it a little bit outside of our canvas that we just defined here, and that will give us the illusion of having some offset. So let's try to do it with positive values now. We can set that we're going to do it in plots and plots. That will give us a plot of offset, but it's going to be positive. And let's do that right now and see how it looks. Right now, if we go to our land, this is even worse, right? We have a lot more water and our plot is gone. So what we need to do is actually have a less margin here to display our map. So we're going to do the following. We are going to define some offsets here to actually make it work. And for that, we need to have a look to our map first. So allow me to go here. And we are going to check our map. And actually, what we have here is exactly one plot. So we need to have one plot up in the two directions, and we have two rods, right? This rod that we have here, but the other road, the other dimension of a road also here, because it's like if we had another plot and another road here in order to build this one a little bit up where we need it. So we're going to do that. We're going to include this and this, and we're going to have this one all multiplied times -1 to make it negative. And that's just for legibility. I could just add the negative sign there, but I like to have the -1 so you guys can see what is actually happening more easily. And it's a little bit out of focus, and that's because we actually only needed one road, I think. So let's go back. Eliminate this. And that's exactly what we need. I calculated badly the spacing, so it's only one plot and one road that we need as offset there. And let's just refresh. Perfect. This is what we want to have. Is in the center, and we have exactly the location of the plot that we wanted to have there in the center. Now we want to have something else. We want to have some pointer here that allow us to signal that this is the selected plot, and that's what we are going to do right now. We're going to draw a rectangle here in our canvas that will signal that this one is actually selected. So let's go to a function here that we can do in a canvas. We're going to do the following. We're going to do main context, and we're going to struct rectangle, and we're going to struct it in the position 0, 0 with dimension of plots and plots. We are going to go back to our website, and we're going to refresh, and here it is. We have a rectangle, but we have the same problem right now, right? It's appearing exactly in the corner, and we want that one to be pointing directly to our plot here. So we're going to go back and also fix it. So instead of having it here in plots, we are going to have some offset there. And here is where we're going to need the following. We're going to have a plots times plus 2 times roads, and the same here. Now we go back to our website, and here we are. Is exactly where we want it. So this is cool, but we have to animate this later on. So we need to have a way to manage these coordinates that we are hard coding right now in the drawing to work when we have a dynamic interaction with them. So that's what we're going to do right now. First of all, we're going to do this in a way that we trigger this when we have our image on load, because if this image is not cached, then that will give us something quite unexpected. It might not appear because this is going to be triggered when that image doesn't exist in memory, and that's not what we want. So we have this one here, and now we are going to do something else, which is to isolate this drawing of things that we have here to a more sustainable way of managing it. So we are going to have the following functions here. We're going to have a function to draw the image, and that's what we're going to include after this function here, draw canvas. So we have this to draw map section, and what it's going to take is a context, and we have where we want to draw the image, and then it will draw our word image on this context. So that's perfect. And then we're going to have another interesting function which is going to do exactly the same, which is going to draw the rectangle. So we're going to have this draw cursor also in an XY position, but we have that the length is going to be the plots. So that will simplify things a bit, but we want to manage this dynamically. So we're going to have another function that we're going to call to initialize our maps. And we're going to put it just below this one here. And we're going to comment the parts that we have not solved yet. And here we are going to call it directly here, and this we can erase because we don't need it anymore. We are just drawing a map section with our function here and drawing the cursor with our function here, but we need to do something with it, right? Where we're going to draw our map section. So for this, we are going to have some variables that we're going to call map view. So let's go and start generating some state variables that we are going to be using for managing these things dynamically. So let's go to them. So we have these map views, and for them we are defining that they will have a map offset that we are initializing like this. What we have here is the initial offset that we know that both in the XY coordinates is just a plot and a road, and we don't need this +1 actually. It's just something to signify that we are getting them in a positive number, but here it is. And then we have these initial offsets converted to negative, and that will give us these map offsets in this map view constant. Now let's go back to our initialized map, and it's drawing the map section in the context on those offsets. Then we have the draw cursor, right? And then where do we want to draw the cursor? So we are going to have some constants to manage that, and those constants are here. We know that the plot view offsets, that means how far is the plot that we have in focus from the general area of the map that we have in the view, and it's always going to be one plot and 2 rows of distance from the borders. So we have that, and that gives us where we want to draw the cursors. And we are going to define that we are going to draw it in the plot view offsets, and that's it. And we can refresh everything, and exactly everything is working as expected. Now that we have done this part, we might want to generate the visible plot in its own view. And for that, we need to draw another map section, which is what we have here. And we're going to draw it in its own context. And we are going to draw it in the plot view location, but we don't have those plot view locations yet. So let's get to define them. And here we are going to define them in another state variable where we have that the plot views are going to be initialized to 0 at this moment. We need to be able to initialize these plot views to the actual locations that they should be. And for that, we're going to create this that is going to be called update plot location. And we are going to create a function to update the plot location, and that's going to be very simple. We're going to put it here. And what we are doing is just updating this state variable that we have here, plot view location x and y. And we're defining that those locations are equal to the map view offset plus the plot view offsets. But if you remember here, the map view offsets are negative. We need actually to be able to add the plot view offsets, which are the ones that are pointing to our plot here. Remember that the plot has certain space between the plot and the borders in this area over here. So we want to add this up. So we have certain offset here, and we want to actually only capture this area of the map. So for that, we need the addition to be positive. So what we're going to do there is just multiply the map view offsets times -1 to make them become positive because they are negative right now. And then we are going to add the plot view offsets to them, and that will give us the new or the actual plot view locations at this specific moment. Every time that we move the map view, this plot view has to change as well, and that's the reason we are creating this update plot location. So we have that properly set up, and if we go to our map right now and we refresh, we are not seeing them. Let's go to the developer tools to see what is going on. Plot context is not defined, and I think this is something that we have forgotten to actually just uncomment. We have only the context of the main canvas, but we need also something like this to get a context for our second canvas, which is the one that contains the plot. So we're going to define that one as well, and is very similar to this one. We have not defined the dimensions properly here in our draw canvas function. The height and width of this plot should be only of the height and width of a single plot. So we did it already, we fixed it, and here we have it. Everything is perfect. We have our current plot working properly, and everything is pretty nicely rendered. But there are some things that we are still not managing, which is being able to switch to other plots and work with the map, which we're going to start right away. We have our map properly rendered, but we want to do a little bit more than this, right? We are going to want to be able to move around. So we're going to include these functions for moving and animating everything. But first of all, this function, which is very simple right now, that is going to be called move, and is going to take a direction. And this function will verify if the move from our user is valid, and if it's valid, it's going to say console log okay, and if not, we're going to have this else here, and we're going to console log nope. And we just want to verify that we are not getting out of the boundaries of our map here. And for that, we're going to capture certain actions or events that our user is executing. And according to those actions, we are going to perform some action ourselves. So we're going to go here, and after drawing the canvas, we're going to listen to a key down event, and we're going to perform this function move whenever a key is pressed. So we're just capturing the key down event, capturing what key was pressed, and we're going to capture that and execute our move function. Under this move, we are going to have this validate move, and we're going to have the following. We are going to capture the direction of the move, which is basically the key that was pressed, and we are going to perform certain actions regarding that direction. If it was arrow right and the plot view, which is the coordinates of our plot, is equal to 5, then that means that the move is not valid. And what does that mean? Well, I think it's better that we go and do it with the arrow left case here. So let's say if the plot view plot x is 0, which is our initial status, right? The plot x is 0 because we're starting counting from 0 actually. And that means that when we pressure the arrow right, this move should not be allowed because this plot is the last one that we have here. So this should not be valid. Going up also should not be valid. It should be only be valid to be going left or down. So that's what we are capturing there. And also in the same way, if we go to our map, here we are, this is 0, 1, 2, 3, 4, 5. If we are in plot 5, we should be able only to go left, not right. And also, we should not be able to go up. All plots that are in the x-axis being equal to 5, they cannot go right anymore, they can only go left, and depending on their location in the y-axis, then they can go up and down. So that's our logic here. If we want to go down and we are already in the lowest plot, we cannot go down, so this is going to return not valid. And if we are in the upmost plot or in the leftmost plot, conversely, we cannot go up or left anymore. I'm doing it here with the arrows, but you can do it with WASD, and that could be actually better because the arrows might cause some funny effects if your screen has some content below the fold, and then the arrow up or down might have a certain behavior there. But just for this example, we keep it like this, and let's refresh. Now, if we move right in this specific case, right now I will press the right key, it should tell me that it's okay. If I press the right key, okay. If I press down, it should tell me okay. If I press up, then it's telling me nope. And if I press right, it's going to tell me nope. So we are okay with our validation of the move. Now we just have to reflect those actions that we took to actually move us through the map. Now what we want to do then in this move is that we are not going to be controlling for this else anymore, and we are going to do something here. If the move is valid, we are going to update the data of the view with the direction that our user wants to go. And then we are going to create the function to actually update the view, which is just going through our state variables and basically updating them according to what is the direction that our customer or user is going. So we are going to include another function here below the validate, and we are going to call it like this, update view, and we're going to just get this here. We're going to comment this update plot location, which we are not actually getting right now, and we have the following. So if we are going right, we want to add one value to plot x, plot in x and plot in y, and those are the coordinates of the plot, and of course we are starting with the plot 0, 0. Now if we move right, we are basically updating to be in another plot, and remember that the reason that we want to update that is that we are using those coordinates of the plot to validate actually the move. So this is quite important. Then the other thing that we want to update is the offset of the map, and that has to do with the map view, which we have here. Remember that we have some initial offsets to put our plot in the center, the initial plot, the plot 0, 0, and we have those offsets set up here. If we're moving right, we are subtracting from the offset because that means we're getting more inside our map, so we need to offset it a little bit more. So that's what we're doing, and if we are moving down, also we are doing the same. We're getting more inside our map. If you remember, those offsets start by being negative actually. So when we subtract from them, then basically we are making them bigger in the negative sense, and when we are adding to them, we are actually make them smaller. And then after we have done that, we're going to update the view, and we are going to move the map around to the new positions of the view after we update the direction. So let's do it right now. Let's take a look. Let's refresh. And right now, this rectangle will disappear, and the current plot, we're not drawing it there. We are just going to move the map. So it's working. We're moving our map, and right now we have in focus the last plot of our map. So if you can see here, just with this little animation that we included, which is just moving the offsets of our map, making them greater or smaller, we can just move around our map very nicely. Here we have it. But there's a problem here that we are losing our initial position and our pointer. So we're going to include that cursor also there. And it's going to be very similar to what we are doing here. But we need to update the plot location first. So that's going to go here. And then after we updated the plot location according to the new coordinates of the map, we are going to draw the cursor. And when we do this, we actually can also go back and draw the map section as we are doing with the initialization. So let's do that. This is going to bring our cursor, and this is going to bring our plot in the plot section as well. So let's go to it. Let's refresh and let's move around, and here we have it. Everything working perfectly here. As we move around, we have all the animation completed. We have everything properly animated. We are just moving from one side to the other very, very nicely. Here we have it. It's quite addictive just to move around our map. Here it is, guys. We have our animation finished. Right now, we just need to bring the information about this plot of land to be shown. Now, time to get our data for placing in the form where we're going to allow people to get assigned or claim plots. We are going to do that very easily because it's basically all information that we have in our states. So we're going to go here to the end and we're going to add it here with a function that is going to be a UI function that we're going to display like this, and we are going to just get some information from our state. We are going to do something here that we're going to comment, and right now let's explain what we're doing here. We are going to generate a plot ID that we are going to need in order to identify the specific plot. We have certain characteristics of the plot in our state that identify what is the position of the plot regarding our grid here, that it's X and Y here. And we have the location of our plot, which is basically measured in pixels, or where exactly in our map that plot starts. We don't need to have dimensions because all plots have the same dimensions of 9 tiles on each side. So we just need to have the point where it starts, and we're going to have everything correctly located. Now, all of that information is unique per each of the plots, but we don't have a unique identifier for them. So what we're going to do is actually get the plot location and the plot coordinates, and we are going to get that stringify, and then we're going to hash it. For this, we're going to need the ethers library, which Moralis already offers for us, but we need to get it from the Moralis package. So for this, we're going to introduce another constant here, and we're going to introduce it as Web3 constants, just on top of our canvas functions here. We're going to call it Web3 constants, and we're going to get ethers is equal to Moralis Web3 library. So we have access to ethers, and that's going to be useful to get this externify thing going on. Then we're just getting the plot XY and the location XY, and our plot ID was what we got here. So that's our data. As you might have suspected, we are going to need to generate it also every time that our customer or user makes a move. So we're going to need it here, and we're going to just call it set plot data, and that's it. But there's something here that I noticed that is going to be nicer if we put it at the beginning. After we update the view, we update the plot location, and then we draw our map section, our cursor, our other context, which is the map, and then we load our data. That looks okay. Refresh, and is working nicely. But as you can see at the beginning, we don't have it. Let me refresh again, and we don't have it. and this is not cool. We need to have that also at the beginning. So for that reason, we are going to need the initialize map here to also include this setPlotData function. And we had it at the end here, but it's okay. We just erase it, refresh, and here we are. We have from the beginning all the data. So that's perfect. Now, what else do we need? If we move around, we notice something. There are some areas that are actually not plots. This one is, but this one is only water. These are going to be our commons, which by definition should not be claimable. You don't want someone to own a piece of water and actually no one will buy it, right? That's owned in common by everyone. And there are regulations for that in the real world. And also in our metaverse, we don't want that to be owned by anyone, mainly because you are not going to be able to build anything there. So we need to have that defined, but that's actually quite straightforward. We are going to create another set of state here that is going to define what plots are not assignable because they are commons. So let's go back here to our state and we define another state here that we call unassignables. And this is something that I just went ahead and did. And the way that I got it was, as you guess, I went to all the plots that are not assignable and basically I just copy their plot ID and get it inside this array. Just copy paste, hard code it. That's the easier way to do it. So we have that one there, but then we need to have some way to verify that these plots that we are in a specific moment are assignable or not. And for this, we need another UI function, which we are going to call is plot assignable. And we are going to go with the UI functions over here. And this is going to be very easy. We just give them the plot ID and is going to tell us what are the actual plots that are included in this unassignable variable that is the array that we just created. And if the plot is unassignable, then we're going to deactivate the claim button, and if it's not, we are going to have that attribute removed. This is the easiest way to manage this. This attribute might not exist if that plot is not disabled, but if we have this structure of that decision here, is going to allow us to manage both situations in the same logic to basically block and unblock the claim button according to the plot that we have. So what we want to have here when we set the plot data is defined is the plot is assignable. If you notice here, we have the update plot location in our update view, but I think it's better the way that we have it right now. We repeat ourselves a lot less with the current structure that we have. Now we should have that one ready. We refresh a bit. We have our plot here. Let's move to a plot that is unassignable. And we can see that all the unassignable plots have the button claim inactive, which is what we wanted. So that's great. Now we just need to integrate with the blockchain, which is what we are going to do right now. But first, we're going to deploy a very simple smart contract. For the smart contract, we're going to do something very, very simple. We just have this contract here, which is almost entirely derived from the Open Zeppelin ERC721 contract, which is a standard. And we are just modifying a little function that we might need to use for our land application. everything here in the constructor is very easy. Is exactly just boilerplate almost. And then what we have that is not that boilerplate is this assign function here. And what we're doing is just sending a token URI, which is the URI of the plot of land or the metadata of that plot of land, where that plot of land metadata will live in the IPFS server. And we're going to do that with Moralis. And we're going to send it also the bytes ID, which is our plot ID, which we have here. For the NFT token ID, we actually don't have in the standard definition that OpenZeppelin offers us the possibility of have the token ID being a bytes 32 structure, which is the hashed object that we have in our UI, but we can, using this ABI decode, convert these bytes that we are passing to their uint equivalent. And once we have done that, we will have a token ID to use in our NFT that we are minting here through this function. And then when we do that, we set the token URI, and then we emit this event, which is going to contain the token ID, who is the assignee, and the bytes ID that we started with. So that's very easy. And then we have other function here, which will just serve to identify if a specific plot of land exists or not already as an NFT. And this will be useful because that's basically how we're going to identify if a plot of land has been claimed or not. So same game that we're playing here. We are just taking this plot ID as bytes, but we're converting it to uint, and then we interact with the standard functionality. That's all for that. So we're going to deploy a version of this contract right now. I'm connected to Web3, injected Web3 in the remix. So right now I'm deploying this contract in the Mumbai testnet of Polygon. And here it is. I have my contract properly deployed with its ID and everything that I need. Now I can go back to my project to set everything for connecting this with my UI. The other part that I need is Moralis. We are here in Moralis.io, and I just created a server that I have in the Mumbai testnet with its specific configuration here with a URL and an application ID. This is going to be very necessary for us in this project because we are going to be interacting with IPFS, and we need to have the user authenticated. We are going to be able to use all the functionality of Moralis for this. We would even be able to track contract events if we wanted, but we're not going to do it in this instance. Let's get to connect to the blockchain in our UI. For this part, we need some other constants to initialize our Moralis server, because that's the only way that we're going to have access to IPFS. So we go ahead and create those at the beginning. We are going to have them as initializing constants. So we have access to our server here, and we are going to do something else, which is creating more Web3 constants. So we have our Web3 constants over here. And for this, we're going to have the contract address, which is going to be the contract address that we just deployed in our remix. And we are going to get also the ABI, which is something that we're going to get from remix as well. So let's get to it. We're going to have these two here, and I will go to remix to show you how to get it. So if we go to remix here where we just deployed, we have some address here, and this address is the address of our contract. So we can just copy it from here, and that's what we're going to bring into the Moralis contract that we have here, into the Moralis UI. So this is our contract address. Then the ABI is something that we get from another area of Remix, which is in the deployments of in the compiling area. You have to be very sure that what you are getting is the ABI of the contract that you have in view, which is Moralis here, and then you copy it from here. Then to make it look in one line as we have it here in our project, you need to get it into a JSON formatter or something to get it in this kind of layout. But that's it. With this and Moralis, we are able to interact with our contract very easily, which is what we are going to do right now. We have everything here for our drawing functions, our animate functions as well, our UI functions, but we are missing something here, which is our Web3 functions, and that's what we're going to start tackling right now. So the first one of our Web3 functions is going to be the one that we're going to use to initialize Moralis and be able to authenticate our user. So this is very easy. We have a login here that is just giving us Moralis authenticate, then a sync, and then we're changing the network ID or the chain ID to the Mumbai testnet of Polygon. So that's one. Then we want to start our server, and this is something that we're going to have at the beginning here as well. So we're going to have this, and we are going to have our login here, which we just created, and after that we're going to create our canvas. Let's make sure that everything is working correctly. And everything is working correctly because we have our MetaMask appearing. And we appear connected. So we are ready with what we just added. Now we need to actually put the meat, which is the integration with our contract. So for that, we are going to start by a very simple function that we are going to create right now that is going to tell us if a specific plot is assigned or not. This is just to illustrate how we interact with contracts with Moralis. So here we have a function in our contract that is just telling us if a plot exists or not, and if it exists, it means that it's assigned. And if we go to our remix, we can check in this section that we have this function over here that is called exist, and it takes the bytes ID of the specific plot and will tell us if the plot exists or not as a boolean. So how do we call that in our project right now? And that's very easy. We are going to have the contract options here with the definition of our contract address, the contract API, the name of the function, and the parameters which are taken from our contract. It takes a bytes ID, that's the name of the parameter, and the value that we want to pass to that one is the plot ID, which we are getting here. And then we are returning the await of the executing of the function. And Moralis is doing all the heavy lifting for us. So that's one of the functions that we need. The other function that we need is also related to interacting with the contract. And we are going to use it to claim the land. We are going to call it mint because actually what it's doing is minting an NFT. And we are sending there a token URI, which if you remember is what the specific function is taking in our contract again. So let's go back to our contract, and here it is. We're going to call this function assign. We need a token URI and a plot ID, but the plot ID we're going to get from our UI, so we only need to get the token URI, which we're going to get from IPFS, but that's a little bit later. So let's go back to our project, and for this one we have these specific parameters. Contract options as well is the same thing: contract address, contract API, the name of the function, and its specific parameters. The token URI is what we are passing here, and the bytes ID we are getting from our UI. Now what we are doing after getting that is trying to call the blockchain and execute the function. And if everything goes successful, we want to display a message that tells us that the transaction was confirmed with this transaction hash. We are getting this transaction wait just to move forward only after the transaction was confirmed at least one time. Then if we got an error, we're going to display a message that is going to tell us that the transaction is reverted, and we're going to console log whatever we got in the console. Now, if you notice, we are sending this as display message, but we don't have that function yet. So we're going to create that. And that's a UI function. So let's go to create it. This is going to be very easy, actually. It's just a little trick. So we're getting what is the message type. And the message type is going to be either 00, which is a successful message, or 01, which is an error, and the message. Then we are just mapping an object here that is going to return according to the code certain div element, and then we are going to select the message type as inside this object that we just created, and we are going to display that inside notifications, which is an area of our index HTML here, actually here. So that's what we are doing here, and we're using that in case there is any error. Now that we have those two, we are going to get the function for assign a plot. So let's go. And this one, what it's going to do is be able to trigger the functionality to put the plot data or metadata in this case into IPFS, and then send that to the function mint that we created here. So this is very easy. We are going to get the plot ID, and we are going to get a function that we're going to get here as const assign. That is the function that is verifying if the plot is assigned or not. We are going to comment it for now, and also we are going to comment this area because that's what we need to do right now. So notice that we are not verifying yet if the plot is assigned, and since our contract is new, no plot is assigned yet. So we're just going to get the metadata with the plot ID, the location of the plot in XY, the coordinates of the plot, and all of that is in information that we have in the UI. And we have certain image that we're going to give it just to appear in the NFT marketplaces, but that's not related to our Metaverse land. It's not going to be a map or anything. It's just going to be a Moralis logo for now because I like it for Moreland. Then here we are going to get all of that metadata. We are going to convert it in JSON file. We are going to encode it, and we are going to get that Moralis file saved to IPFS, and then we're going to get a URI, and then we're going to mint it. So that's basically what we are doing. So we are almost done right now. And let's refresh. We are going to get the MetaMask popping up to sign in and authenticate, and then we can move around our plots of land. Now let's say that I want to buy this house here. I will claim it, and nothing will happen because I forgot to do something very important. I forgot to call this assign plot function from my HTML. So let's do this here and on click. So assign plot. That's it. We have everything complete right now. Let's go back to our land and let's refresh. MetaMask is gonna trigger again. There's a way to deal with that, but I don't think that's a good investment of our time in this video to get the MetaMask to just save the session through Moralis. Now let's do the showing of our development tools here and get the plot that we want to buy, and I still want to buy this little plot here, so let's claim it. My MetaMask is triggering because I'm about to claim that plot. Let's get it. And we're going to wait for the notice to appear that my transaction was confirmed. And we have my transaction here, so that means that I have that plot assigned to my name. Let's go back here to Polygon, and I have this specific token ID transferred to me, and it's from Moralis MLND token. So I have my plot that I just bought. But we are not complete, because what will happen if I want to actually buy the same plot once again? And I will try to do it right now. So let's go back to our land. And it's not going to be that cool. So let's try to claim it again. And it says transaction reverted, see console for details, but this is a little bit not good, because this could be any kind of reverted transaction. And we took the time to kind of like do the route to IPFS and everything just to get this one, but it was already there, and then this was not a very efficient way to manage it. And that's the reason that we had something else to deal with this, and we're going to return to our logic, and that was the part that we commented. So we're going to have a function here being called, and we're going to have all of this logic inside an if statement. So we're going to have this constant assign to be equal to isPlot assign, and then we're going to get if not assigned all the logic for minting. The actions will happen only if the plot is not assigned, but if the plot is assigned, we're going to display this message, plot is already assigned. And that's what we want to happen, so we can display that almost immediately without having to execute a lot of logic for that. So we're going to refresh. It's better to wait for MetaMask to trigger. So let's go back to the plot that we wanted to claim, and let's claim it now. And here I got instantly the message that the plot is already assigned. So that's it for this specific project. I hope, guys, that you have enjoyed it. It's a little bit different of the things that I have been doing lately, but I kind of think that this was interesting because of the conversation that I have with my friend, and I checked the Decentraland and the Sandbox projects, and I thought that I could introduce you to how they work a little bit in a more simplified way. Of course, not the way they manage it, but very, very similar in the basics. I want to also tell you that the way they manage to show in the NFT trading platforms the plots as they are, and even in some cases show the updates of what has been built in those plots of land, is that they are not actually storing the image in IPFS. So instead of having the image, they just mention in the metadata the link for the image is just a call to their API, and of course that can retrieve whatever image in any changing state. That's quite cool, but you are relying on an API call to a centralized server, a compromise to have the functionality that those protocols need to be updated in real time. Even IPFS gives you the guarantees that whatever is stored there is there with the same characteristics, that is not being tampered with, but it doesn't give you the assurances that someone will pin it in the system for you. It's just a way of indexing, but not actually to store. You need to use Filecoin, or you need to use another service like Piñata to have it actually pinned. Moralis also offers that service, and that's what we have done right now. So I hope that you have enjoyed. This is Daniel. See you in our next video.